So, hello. My name is Henrik Wallström, and I come from a company called Einride. How many of you have heard of us? Good. I think our marketing department has done a good job then. The foundation of Einride is based on three things. We want to make a change. We see that, I think everyone in this room is aware of that. We have a huge challenge ahead of us in terms of transport emissions, especially from heavy goods transport. And we really think that we can do a change there. We are based on two big mega trends that we can see. It's electromobility, or more specifically battery technology, and self-driving. So if you combine that and you think about how can we do transports differently, you probably, hopefully, end up with the same conclusion that we did. We started in September last year, so we have had a very quick trip to where we are now. During this year, it's been really interesting to see that the whole society or academia and the companies that we talk to, we really see a shift in mindset. And that's really what's required to make this happen. But if you combine these mega trends and you think about, okay, how can we do this differently? If you talk to the customers and ask them, what do you want? This is what we came up with. So this is our Tpod. It's a transport pod, hence Tpod. It's all electric, it's cost competitive, and it's disruptive. The vehicle is about 7 meters long, 3.8 meters high, 2.5 meters wide. Total weight is 20 tons, goods capacity is 12 tons. The range is 200 kilometers on paper, 150 kilometers in reality. And we think that this is one of the solutions to reach a sustainable goods transport system. It's not, it will not cover all, but for many transport, this is a good solution. All electric, basically the battery technology that we have and the increase in capacity and the price decrease is what makes this possible. If you do the maths, you will end up with a sweet spot around 20 tons. If you go above that, you have issues with battery taking away goods capacity, and also the business case becomes worse. But the key factor here is the removal of the driver. So this is totally cabless. There is no driver space in this. There is no persons will sit in this and drive. That is the key. If you remove the cab, I have a background from Volvo, and we usually said that 60% of the cost of producing a truck is related to the cab. It's a very complex environment, a lot of electronics, a lot of safety systems. You need to protect the driver, you need to protect everything. Remove that, you remove a lot of complexity. That makes this product cheaper to produce than a standard truck when produced on an industrial scale. The other benefit is, of course, the operational cost. The removal of the driver reduces the cost of transporting goods significantly. In Kenya, it's a different case. In Kenya, the benefit here would be the electric drive, for sure. But in Sweden, we can say that the driver represents roughly 50 to 70% of the transport in general. And if we add the added benefit of removing the electrical drive, we also remove the total cost of diesel. So a tenth of the cost to propulse the vehicle compared to diesel. It's a huge benefit. So what Einride is a system creator. So we're the next generation transport provider. We're a transport company. We're not a hardware provider. We are not a logistics company. We are not building a plant to build the Tpods. That is not our intention. Our intention is not to start building warehouses and compete with 3PL. We're a transport provider. We will provide road transport from A to B, and we will do it extremely efficient. That is what Einride is. To do that, we need a system. And of course, the Tpod is key in that system, but it's not, a system is not whole without all components. So we will use self-driving Tpods. We will implement and use a charging infrastructure to support our system of Tpods. We will work with remote control operators. We will need to have some sort of remote control to monitor our fleet. You can think about it like a flight control tower that has the possibility to monitor many units. And we need to have an extremely efficient order and fleet management system, because this is a new ballpark. Here we're talking about no longer any limitations on driver time, no extra cost of driving during the night. All those limitations are removed. What we instead end up with is not more complex, but a complex scenario in terms of handling and optimizing the way you set up the transport in terms of battery capacity. So 150 kilometers doesn't sound much, But if you remove the driver, you also remove the most significant cost of charging, which is standing still. As you don't have a driver, the only cost you actually have is the amortization of the truck while standing still. That is the reason why it's difficult to put batteries on an existing truck today, that you need to stand still for 2 to 3 hours at a 500 SEK hourly cost. That cost is removed. So basically, we don't say that the range is not an issue, because we can just charge. We can go from Helsingborg to Skellefteå. It will take us longer. But as long as the lead time is not critical, if the transport efficiency will be a lot higher in that type of setup. And of course, as I mentioned before, it's cost competitive. So no driver means reduced running cost. Electrical vehicle also have a lower maintenance cost, a lot less moving parts. So it's a lot easier to maintain and handle the aftermarket. Reduced driver cost, we're looking at fully implemented, we think it's a 1 to 10 ratio. So one operator can, if correctly planned, handle and monitor up to 10 vehicles. Not drive 10 vehicles, but monitor 10 vehicles. Increased operation hours. Night running is a big deal. We have big traffic congestions during the day. If we can do the transports cheaper and more efficient during the night, it is possible with this type of system. Electric drive means it's more silent, so it's possible to drive during the night. We don't have a driver that gets tired. We don't have a driver that needs to stop and rest. We can run 24 hours. And one of the biggest benefits that we see, and also what is disruptive in terms of how the logistics setup is done. Today, the system is built up on that we have bigger, longer, heavier trucks that transport goods from A to B. They need to be bigger to be able to get the most out of the driver and the diesel engine. But we want to look at it from a different perspective. Coming from the automotive industry, just in time is extremely important. Everyone is working with lean, and the lean has spread to all other sectors. Almost all customers I talk to, and it's a big goods owners, they definitely see the benefits of smaller deliveries, more frequent. It will bring down the cost of capital. It will increase the complexity in the whole goods distribution system, and it's no longer related to the economies of scale of a bigger vehicle. You can reduce the size and still maintain a really good business case. So it is, in this scenario, we have a better business case than today, and it's also better for the environment. And the environment, of course, is our biggest driver. Of course, we can see that depending on how you count, we see a large reduction in carbon emissions. Of course, we assume using green electricity. We also have the whole debate about the vehicle itself and the battery, and that is tons of research done on that area now. We are fully aware of that. That is something we need to work very closely with. And we're happy to see that we have Swedish companies also starting to invest in battery capacity, such as Northvolt. So we'll hopefully have a good possibility for industrialization in Sweden in the future. We don't have that today. Electric drive, silent. The societal impact of a 20 to 25 lower decibel level is really hard to quantify, but we know it's there. The background noise from big roads, it is an issue. It's hard to quantify, and that's more up for research to quantify that, but we know it's an issue, and it's a health issue that is arising. We can combat that by using electric drive. And compared to other alternatives, such as HVO and biodiesel, we are really big proponent for carbon emission-free fuels, of course. But we also see that the added potential of going from a combustion engine to full electric drive, that you also remove all the unhealthy particles and NOx. That is an added benefit. So what enables this is basically these three trends. So self-driving is, of course, the core in what we're doing. But the thing with goods transport and what makes this case so good is that we don't need level 5 self-driving to do goods transport today. Level 5 self-driving is needed if you're going to do last mile, city distribution in extremely complex environments such as central Gothenburg or central Stockholm. That is not the area we will operate in primarily. We will operate between terminals, between warehouses, between hubs, on big roads, on highways where the traffic complexity in terms of self-driving is a lot less. And the possibility to bring in a remote driver, in other words, a human decision into the equation when needed, also reduces the complexity quite significantly. We don't have to rely on the Tpod to take all the decisions. If we end up in a difficult situation where we have a traffic accident, police control, or a really complex pedestrian crossing, we just program the vehicle to safely stop, call for a driver to take the decision, and make sure that it can safely pass that obstacle or hurdle. And that is the logic we use. So we try to not address all the complexity in the self-driving. We try to remove complexity from the transport. And that is really a great possibility when talking about goods transport, because it's almost always from A to B, and it's almost always planned. And the flows we're looking at, we're passing by the same pedestrian crossing 10 times per day. Then it makes sense to invest in technology that can reduce the complexity of that crossing. So that is our approach to self-driving, and that is what we are developing in terms of self-driving capability, of course combined with the remote control. And battery capacity, of course, Tesla has been a driver in that area, or Panasonic, I would say, because they are the ones behind it. We see a very positive trend, both in terms of cost and power output, but also a lot of research going into the recyclability. We heard Mats talking about that earlier. That will become a hugely new market in terms of how do we handle all these batteries, because that's going to be a lot of batteries. And we're really happy to see that there's a lot of research going into that area. And that also makes this possible, that in 5 or 10 years, the Tpod will perhaps be able to go double the distance or the same distance but half the price. That is the type of disruption we see in battery technology. It's moving really quick. Combine that with what we see in trends in terms of solar power that's reaching 0.4 cents in solar power in some cases. That is the trend we're looking at. So if we're looking at decentralized grids or that type of power input, the business case for battery-driven electric vehicles is really good. And of course, the connectivity. We don't require connectivity because we're not going to drive it 80 kilometers per hour on the highway with a remote control. We can do this today with 4G, but of course 5G helps. The security and the whole safety measure combined with the remote control will be more beneficial using a more efficient system. And we're glad to see that Sweden is at least being a part in the front row in that race. So we really have a good industrial and academic setup in Sweden to make this happen. The problem is, or not the problem, but we think that we are ahead, but we are not. In terms of electrical vehicles, we are not ahead. China is ahead, and it's been ahead for many, many years. So we have some catching up to do, both in terms of electric vehicles, in terms of batteries, but we are ahead on competence in some areas, and that is what we need to build on, what's really important. Our target for 2020 is that we will install 200 Tpods between Helsingborg and Gothenburg that has a yearly capacity of 2 million pallets. It will, of course, not look exactly like that. It will be different hubs going in between, but that is the capacity we're aiming for and the industrial capacity we're ramping up for. We will see that if we implement that, that will be the equivalent of reducing 400 passenger trips between Helsingborg and Gothenburg. And 200 vehicles sounds a lot, depending on how you count, but it's somewhere in between 1 or 2% of the heavy goods transport going from Helsingborg to Gothenburg each day. Approximately 4,500 heavy vehicles pass by Helsingborg northwards every day towards Gothenburg. So it's a hugely traffic dense highway. But the goal is 200. We already have customers sign up for 60% of that capacity. You probably see in the press release with Lidl. We're working very closely with Lidl to make this happen. And we're also working directly with some of the biggest goods owners in Sweden to see how can we do this and how can we make this happen. What I see in terms of challenges is what Malin was talking about earlier is really important, the societal aspect. How will the community adapt to this? That is one of our biggest challenges. The technology is there, the customers' demand is there. We can make this happen, but we need to change the way we think. So, thank you.